Welcome back. Let us consider illustrations of some real life systems. Here you have a photograph of a power plant. There are a number of units in this station, but in the forefront you will see one thermal power plant. It takes in coal, produces electricity, it takes in cooling water, slightly warmer water is thrown away, and through the stacks you throw away flue gases, the burnt product, carbon dioxide and other stuff. Okay. We may consider the whole power plant as our system. It will be an open system because it takes in coal, throws out through the chimneys and exhaust. Because it is coal, it may contain some ash which does not get burnt, so ash is also discharged. Then you have cooling water going in and cooling water going out. And then of course you have energy output as electricity. This whole thing can be considered to be a power plant, and we can apply our principles of thermodynamics to such a large system. However, it is also possible to consider components of the power plants. For example, the main subsystems in the power plant are the boiler, sometimes called the steam generator. Then steam goes to a turbine. From turbine, low pressure steam goes to a condenser where cooling water comes in. So this is the cooling water circuit. Steam condenses, the condensate is pumped back into the boiler. This is a very simplified form of our power plant. Now the turbine produces mechanical power which is passed on to the generator creates electricity which is the output, final output of the plant. Apart from this, you have in the boiler a furnace in which we put in coal. Air also goes in, it is required for combustion. Ash discharged at the bottom and flue gases at the top. Now this is the approximate internal detail of the earlier system which we saw. So I can put a dotted line around all this, and that is essentially the system we saw a few minutes ago. But it is also possible to consider subsystems. For example, this is my turbine system, and I can apply my laws of thermodynamics to this smaller system which consists of the turbine. One inlet, one exit, so it is an open system. Similarly, we can apply the laws of thermodynamics to the condenser as a system or to the pump as a system. When it comes to boiler, we can consider just the water holding and water flowing part of the boiler which converts water into steam as our system. Or you could have the furnace which handles coal, burns it with oxygen from the air and transfer the energy liberated as heat to the water in the boiler. That could be a system. This is just to illustrate that the choice of a system and its boundaries is our choice. If we want to look at something at a gross level, overall level, we can consider the whole plant as a system. If you want to consider subcomponents, study their characteristics, for example, we can have the turbine as a system. To study the details of the turbine, we can even go to the internals of the turbine, and there are various stages. A typical turbine will have anywhere between 10 and 20 stages, stacked like slices of a loaf of bread. Each stage can be considered as a smaller thermodynamic system. And if you really want to go into details, a stage consists of a few dozen to a few hundred blades, and the space between two blades can also be considered to be a properly defined thermodynamic system. So the definition of a system depends on what we want to study and in what detail. Now here we see a photograph of our Earth taken from space. Can we consider the whole of our Earth as a system? And the answer is yes. All that we have to do is set up an appropriate boundary. We set up the boundary and we say this is Earth and its immediate surrounding, that is the atmosphere, as our system. What would be the neighboring system across the boundary? That would be the part of space, part of the solar system just across our atmosphere. We can apply, and we do apply, the laws of thermodynamics to our Earth as a system. In fact, this is what earth scientists and climate scientists do. Finally, we ourselves, each one of us, is a thermodynamic system of the biological kind. Of course, we, any one of us, as a thermodynamic system can be studied thermodynamically. However, the structure and the internal working of such a system is so complex that in this course we will not make an attempt to study that. Thank you.